in the hang of it, it shouldn't be too bad at all. Yesterday, didn't we talk about some properties? These guys. And we have the condensed logarithms, single logs, with products, quotients, and powers. Maybe other stuff too, but the only ones that we can expand are the ones with products, quotients, and powers. Condensed ln, just telling us that this works for specific logarithms too. And then we have the expanded forms, where we have split this up into addition of separate logs, which is legal because of the property. Or the division got split up into subtraction of 2 logs, legal because of the property. Or the power got brought down. We could say power down. The power got brought down, power down for the logarithm. And so yesterday we were practicing, well, this one was weird. These ones were weird because this one was division, but we should have reduced first. And there was this funny, like, oh, 100 is 10 squared, we can go farther thing. These were kind of hard, kind of tricky, but then these ones, I think, hopefully will be much more straightforward. The directions say expand. What are you supposed to do? Expand. How? Using the properties. Whenever you see times, we can make it plus. Whenever you see times, we can make it plus. Whenever you see a power, we can power down. Simplify as much as possible. Whenever you see a square root, we think of it as a 1/2 power that can power down. Whenever we see division, we can think of it as expanding to subtraction. But here was the last thing we talked about yesterday. When we see subtraction in a condensed form, can we expand that? Yes or no? Yes. Look at your properties. There is no way of expanding subtraction inside. In all of our properties, there's absolutely no subtraction that can be expanded. Okay? That brings us to, well, if we're not expanding, I guess we're condensing. And that's what you guys wrote at the beginning of class today, yeah? Expanding like a balloon, condensing like condensed milk. Expanding like a balloon, condensing like bringing together. Okay? Some of your moms go through spring cleaning and condense what's in the house. Some. Others just like, more, more. That's kind of how I am. But condensing, putting together, trying to make it simple, shorter, sweeter. If we have logarithms spread out with subtractions or additions or multiplications, we can condense them into, and the directions even tell us that, a single log. If I were you and you were like an underlining, highlighting kind of person, that's the big idea. Condensing goes to a single logarithm. So as long as the bases match, guys, what kind of logs are these? Oh yeah, there is subtraction, sorry. What's the name of these logarithms? Why are they common?
Because there's no number.
Good, there's no number, and it's literally an log, not an ln. So what's the understood base of a common log? Good. Long story short, their bases match. Oh, subtraction. I can make division. Dun, 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 dun. Who goes on the bottom?
X plus 1 squared.
What should you do before addition or subtraction every time, like PEMDAS says? Multiplication or exponent. Either way, it comes first. When you have a multiplication of a number, a coefficient of a logarithm, every coefficient of a logarithm needs to go up as a power before we ever get to the quotient or product. So if I were you, it probably would be a really, really, really smart idea to give yourself a little hint. Power up. Always power up first. With expanding, we kind of have some options. We have to be a little bit careful with the powers like we saw yesterday. We can only power down if it's an actual power of the term that's inside the logarithm. But other than that, it's not a big deal. But when you're condensing, always power up first. So we should have, before ever going to the quotient, we should have instead realized that this is log x. I said realized. Maybe some of you would need to write it. Maybe some of you wouldn't. But we would need to realize before we ever do the quotient that that's actually an x plus 1 squared. Now we go to our quotient property. And now we say, who is hiding underneath there? We get rid of this random. I don't even know who he is. Go away. Oh, it was my B. That's sad. That's okay. I can write the letter B. There. I apologize. Coming back. I got distracted. What can I do now?
Now you can make them divisions.
Division in a single common log, right? So it's going to be x over x plus 1 squared. Dun, 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 dun. Okay, power up first. Hey guys, how many powers do I need to power up in letter B? Oh, there's more than one? Here's the trick. Matthew's trying to tell us there are 2. And in some ways he's right, but in some ways he's wrong. It's really 3. Do you see why? Because the 4 distributes, right? So the 4 is going to have to come up for the z because it's on the outside of the whole thing and the z plus 5. Do you see it? So it's going to end up being, powering up first, ln of z to the 4th plus ln of z plus 5 to the 4th minus, what happens to the last guy? Okay, now I've fully powered up. The 4 was in brackets. I know it's kind of hard with my little circle. But the 4 was technically before the brackets. And so he needed to get distributed to both logarithms. If there was a 4 in front of both, then they both end up getting powered up. That guy, well, he just had a 2. We powered him up. And now, kind of like PEMDAS again, we go right with our product and quotients. Powers first, now products, quotients. Every time we see a plus, what can we do? Yeah, we can combine, since the bases are the same, into a multiplication. And if you want, you could technically separate this last step and say, okay, first of all, make it a product. Yay, it's a product. And then you could go ahead and say, now make a quotient. But some of you are going to get to a level of mastery where you're like, you know what, I can just jump to the end and get the product and the quotient, and maybe even the powers all at once. Oh, sorry, it's not a 4th. This last guy is squared. But the name of the game isn't necessarily going fast, even though, of course, it's going to be helpful in some ways, as long as you're getting it right every time. The name of the game is getting it correct. So, distributed our 4. They were all powers that needed to power up. We had one product. They're going to end up next to each other. We have one quotient. He's going to end up in the denominator, a single logarithm with a whole mess inside. But it's right. And it's condensed. Jason.
Okay. So I condensed the 2 z's before I put the power 4 over them, so it improved like on the inside, parentheses at the top thing, it was z squared plus 5 in parentheses. So I'm just wondering, is that right?
Almost. The problem was you thought of this as multiplication, which is totally fine. But what I would have thought of it as would be z times z plus 5, all raised to the 4th, because you still need that 4th to power up. But here's the problem. You went ahead and distributed and made it z squared, but you forgot that it should be plus 5z also.
You're right. Okay.
Sorry. So it was almost right. Like I totally, if it was a long answer, I would have been fine as long as you had gotten the 5z too. Also. Got it. So what Jason was saying was like, why can't I do inside the grouping symbols? Totally fine. You could do product first technically and then power up, but just be careful. This whole thing needs to be raised to the 4th. He was thinking of trying to combine, which was good, but you would need to do z squared plus 5z to the 4th to be right. Or, once again, you could have actually gotten to z to the 4th and z plus 5 to the 4th by simplifying one more step. But this is technically right also. Yeah. Thanks for bringing that up, bud. Any other questions on these guys? What if they don't really tell you expand or condense? Just to give you a few more homework helps. What if they don't really tell you to expand or condense? Instead, they give you an objective. They just say find. Find. Well, that's great. It says without a calculator. It must be a nice answer. There's two different ways of tackling this problem. Both of them are just as valid. But I hear from you what your brains are thinking, because I can show you what my brain thinks all day long. It doesn't necessarily help you tackle a problem on your own, right? So someone tell me, is there anything your brain's telling you that you should probably do? A property, a rule, a rewriting? Matthew, what's your brain telling?
I'm thinking that it is a quotient property, so we should expand it.
Pause. I know exactly where you're going to go. Hold on. Who else's brains at least somewhat thought quotient property and expanding? Okay. I'm just trying to think of what the brains are thinking. Did anyone's brain think of negative exponent? That would be nice. But let's do the quotient property just because I think the other things our brains were thinking weren't really productive. So, at least to solving the problem. Let's do quotient property. Matthew, keep going. So you said we should expand it. Keep going. Uh-huh. I'm going to get there in a second. First of all, let's just rewrite it. E to the... Good. Good. The reason why I got a little scared was because it's minus and then a negative, and that's going to... Yeah. So, but I think I knew what you meant. So we're rewriting first. Wait a minute. How did Matthew even go to the 1/2 thingamabob? You guys remember that? The square root is a 1/2 power. So ln of 1 minus ln of square root e. He made it e to the 1/2. And he started actually to go even further. He's doing lots of steps in his head. But can't we power down? So we have ln of 1 minus 1/2 ln of e. How on earth am I supposed to do this without a calculator? Doesn't ln of, which one are you looking at? Pause. Oh, cancel out. What's he talking about? Someone else. Pick up where Matthew left off. Joe. Good. And so log base e of e, they undo each other. My question is, what's left? 0, 1, x? For this piece, what's left is just going to be the 1. For this piece. Now, 1's going to multiply by 1/2, so ultimately there is 1/2 remaining. But remember, whatever's left over is just the power of e. So log base e of e, e is what power of e? Just 1. So you could, if you wanted to, actually rewrite that to be 1. Does anybody remember what happens when you have any logarithm of 1? E to what power is 1? Any base to what power is 1? That's actually in your properties from section 3.2. That any logarithm of 1 is always, always, always 0. You guys might also remember that we had an x-intercept. Y was 0 and x was 1. Anyway, it's another reason. But you end up with 0 minus 1/2 is just negative 1/2. No calculator necessary. Now, I asked a couple of you a second ago. Actually, I didn't know. I was asking the whole class. But a couple of you knew what I meant when I said, did anybody think negative exponents? How could you have rewritten 1 over square root of e as a power, a single power of e? E to the negative 1/2. We could have gone here to here to here? Yeah, we could have. But did the quotient property work also? It's harder sometimes for brains. It just depends on how your brain works. Some of you will see this and be like, oh, sweet, I'm doing that to get here. Then ln of e reduced, the negative 1/2 is left. But some of you saw quotient property. I just wanted to show you that's valid. Do it. You got it. It's good. Jason. Yes, you may. All right, let's see what else we've got. I just had a couple of you that were still writing. Can I dual page it? I think we should still be able to see. I'll make this example a little bit bigger. Deal? Okay, I want you guys to tackle it without me. If you're like, I don't even know how to start, you can reach out to your group. That's okay. They can help you start. Or you can help each other start. But I think some of you, especially since it looks kind of similar, might already... Oh, the directions just say expand. Okay, go. See what you can do. Go as far as possible, but not too far. Uh-oh. go as far as possible, but not too far. AKA go as far as is legal, but it might be a danger in your desire to go as far as possible, to start going illegally. So just be careful. And I think a lot of you at least think you're as far as you can get. Check in your groups and see if they agree with how far you've gotten. It's better to stop early than to keep going too far. Oh, there's a life lesson in that. It's better to stop early than to keep going too far. I'm going to start playing. I don't mind if you guys start talking things out and thinking things through. You guys go far, but not too far. It's so easy to think that you should keep going, but you shouldn't. Why not? Check out your properties if you ever get stuck. If you think you should, but you're not quite sure, is there a single log of a sum that can be broken apart? The answer is no. The only single logarithms that can be broken apart are division, multiplication, and powers. So the danger is to think that you should keep on, ooh, I want to break them up. Well, that's great, but it's not allowed. Sorry. So if you did try to keep going, you're going illegally and it's going to be wrong. Oh, but 6. Maybe e to what power is 6? I don't know. Something in between 2 and 3. Nope. Something in between 1 and 2. How'd I do that? Mental math in my head? I know LNs? No. ln has a base of e. E is about 2-ish, 3-ish. So I thought of 3-ish because it's 2.7. 3 to the 1 is 3, and 3 squared is 9. Well, it's somewhere in between 1 and 2. Anyway, but do we know what it is? No. Anything else to do? Not really. Dun, 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 dun. Who at least got there? Whether or not you kept going, who at least got there at some point? Cool. How many of you guys stopped there? Okay. A couple of you guys kept going. Just be careful. Those of you guys that didn't get there, do you have any questions for me? Okay. What's the main 2 keywords or buzzwords from all of section 3.3? Either or. Either expand or condense. Now, does that mean every single direction is going to have those exact same wordings? No. So just keep both sides, keep all 3 properties, whether you're going from expanding or condensing, going from this side or from that side. Just be aware that some of the problems aren't going to tell you exactly what to do, but for the ones that do, follow that direction as far as you can, but not too far. And for the other ones, just be like, are there any mental math things I can do? Like, any logarithm of 1 is 0. Like, can I make the bases match? Etc. Okay? And then if you do see any numbers, I just want to look at it one last time. We didn't do them today, we did them yesterday. If you do see any numbers like this guy, don't just think about the number that's staring at you, like 8. Think about it as a product, 2 times 4. Think about it as a power. We didn't do it yesterday, and you guys don't have to write it down. But I said yesterday, what do you guys think? Is it a quotient? Is it a product? Is it a power? It could have been all 3. 8 could be 16 over 2, and I could have done the quotient property. 8 could be, here's the one I was thinking of. 8 could be 2 cubed. Well, how does that help? Oh, I could bring the 3 down. And I can make 2 the square root of 4. Oh, that cancels out. 3 times a half is 3 halves. When you are given numbers, you get to choose to make it a product or choose to make it, well, if it is a power, maybe it's not a power. You get to choose to make it a division and then try to use a property to say, can I actually, why are they do this without a calculator? Is there something I can do? And if there is, go for it. But remember, our job is to try to get more familiar with logarithms, to try to master them a little bit better, or at least be more skilled in working with them, getting ready for puzzles that are to come. Speaking of puzzles that are to come, let's start section 3.4. Just start, just a little bit. We're not going to go hard. If you guys notice, 3.4, maybe you don't know my color coding. Blue is usually everything new. Usually, blue's new. Red's usually examples. Black is usually just information in whatever we're doing. And green is usually, if you can see that's green. Can you see that's green? You can see it over there. Sorry, it looks really close to black. Is that better? Is it green? Well, it looks a little different than this though, right? That's actual black. That's like, anyway. No, I know. It doesn't look like it. Anyway, green is review. Green is review. No, it's a hard green. Plus the projection isn't like crisp. It's definitely not high definition, that's for sure. See, when you look at it next to other colors, maybe you realize it's green just based on the color progression, but yeah, anyway. Doesn't matter. Sorry, green is review. So for section 3.4, the crazy thing is, all you guys really, really, really need is the one-to-one property and the inverse property. Wait, we've already done that. Yeah, 3.4 says you're ready for, well, maybe not the hardest levels, but you're ready to at least get into the game. You might not be ready for the hardest level, but you're ready to get into the game at least a little bit. The hardest puzzles are probably in section 3.5. And that's where we have like word problems and actual applications in chemistry and financial stuff. Yeah, radioactive growth and decay with elements. Don't worry, you don't need to necessarily have background in all this stuff. If any of you guys have taken the ACT or a pre-ACT, the science section, we were talking about, no, who is talking? I was talking about that with someone recently. The science section is all about basically reading tables and analyzing the math, which is weird because it's science. It is. A lot of science is data or working with equations, especially in like science labs, etc. So when I say chemistry, don't freak out like, oh, I better have gotten an A in there or else I'm going to fail section 3.5. No, we're going to look very specifically at when these skills are going to be necessary. What kinds of puzzles, what kinds of math modeling equations need you to be familiar with exponential and logarithmic, and how do we put things together? So 3.5 is where it's really the deep end. This is kind of like the kiddie pool in 3.4. Maybe not the kiddie pool, but 3.5 is the last section. No. Not in chapter 3. Because it's so much like building the foundation, building the foundation, building the foundation. You don't really get to start playing with things until the very end of chapter 3, and by that time, we're ready for a test. But we are spreading out these last 2 sections to be multiple days, which is why the test isn't until, maybe check out their calendar next Tuesday? Wednesday? Next week. So you have the weekend where some of you might need to start scheduling with tutors, etc. for this weekend. I know some of you do, and weekends are sometimes good times to meet up. All right, section 3.4. We know the one-to-one property, right? Make the bases match, steal the powers, make the bases or the logarithms match, steal the arguments. This is great. It rarely happens. But it's nice and easy when it does. It's great. It rarely happens. This one, if I were you and you're a highlighting person, this is probably the most important skill that you're going to have to be using over and over and over again. Now, there are skills like being able to read the English, to put it into math, like mathematical expressions. There is a lot of logic and just common problem-solving skills. Maybe not common, but problem-solving skills that are going to be necessary in the hard section of 3.5. But as far as working with logarithms and exponential, the inverse idea is the most important. Because if you have a logarithm that's trapping in a poor little x, a to the power of undoes that. Or if you have an a to the power of trapping in a poor little x, a logarithm unlocks the door, is the key to getting rid of the a. So this is the most important property. At the very beginning of section 3.4, there are some problems. The very beginning starts off super easy, and you might be like, it's not super easy for me, but as far as where you're going, these are like the basics, and I'm curious for you guys to tell me, what property do you think we should use here? Should we go taking log base 2 of both sides, or should we see if we can make the bases match? What do you think? Okay, so let's break down 32. What do you guys think? 8 and 4? Is that good?
Yeah.
Couldn't 8 be 2 cubed? I'm just going to cheat a little bit. I know. But we're in higher math. We know what this whole factoring thing is for. It's 2 to the power of 5. What's it? 32 is 2 to the power of... Haha, if I can make those bases match. What's x equal?
5.
Got it. That's 1 to 1, yeah? How about letter B? Should I do e to the power of both sides? Should I do quotient property? Should I add?
Quotient property.
Why add? You can do quotient property, Jason. You're totally fine. But why is adding nice? Oh, look at that. X equals 3. Now, hold on, pause. Is Jason's quotient property bad? No. There are sometimes multiple ways. What would we say to skin a cat? That's so sad. But e to the power, you never heard that phrase? Never mind. It used to be a thing. Like killing 2 birds with 1 stone. There are some pretty dark, like, common phrases. Anyway. Okay, well, that's fun. X over 3, e to the 0. Jason, would quotient have gotten you there? Yeah. But adding is nice. Sometimes the more creatively you think about a problem, the easier it is. Sometimes it's just a rabbit hole. Okay, do you know that illusion? Alice in Wonderland? Never mind, I give up. So, moving on. How about this guy? Nine is 3. I mean, I see 3s. You guys see 3s, right? But that's a 1 over 3. Negative exponent? Isn't that 3 to the... Careful, but not squared. 3 just to the negative 1. I can make 3 to the negative 1 1/3, or 1/3 3 to the negative 1. It's 3 to the 1 in the bottom. Now, negative x equals 2. Oh, it's 1 to 1 property. But as soon as we get here, pause. As soon as we get here, what power of e is 7? So what do we do? Not 1 to 1 property. We're going to do inverse property, x equals ln of 7. Kiddos, we're going to pick up where we left off tomorrow after grading 3.3. Out of here. Bye, guys. Thanks for the extra 20 seconds. Oh, next. If the test is next Tuesday, it'll probably be due next Wednesday. I'll probably give you until the day after the test, because test day doesn't have a lot of homework.